In this chapter, you will have to think outside the box. This chapter is about logic and patterns, and we'll do things like brain teasers. You'll just really get to stretch your brain. So patterns are everywhere. In stripes in a shirt, in nature. Patterns are pretty much everywhere you look. Let's go find some patterns. Oh, I see some. Okay, so let's see if you can get these. We've got January, March, May. 8, 16, 24, triangle, quadrilateral, pentagon. Can you figure out the pattern and what the next item would be in each pattern? How did you do? Here's one. Wonder if we could figure this one out. O, T, T, F, F, S, S. What's next? I'll give you a hint. O, T, T, F, F, S, S, E, N, T. You got it? So we will explore some patterns in this chapter. First of all, we're going to talk about inductive reasoning. And inductive reasoning uses patterns of observations to draw conclusions. So an example of inductive reasoning might be that I looked around the room today and the first 3 people that I saw were wearing yellow socks. So I'm going to conclude that on Mondays, everyone wears yellow socks. Deductive reasoning uses logic to draw conclusions from given facts, statements, and properties, and previously proven statements. And here's an example of deductive reasoning. I know for a fact that you must pass Algebra 1 in order to go on to geometry. Since you are all in my geometry class, I'm going to conclude that you've all passed Algebra 1. We are going to talk about these terms: conditional statement, converse, inverse, and contrapositive. A conditional statement is a statement written in the form if something, then something else. After the if is called the hypothesis. That's what we will call the P statement. And after the then is the conclusion. That's what we will call the Q statement. So the conditional statement, if P, then Q. The converse is a statement written by flipping the hypothesis and conclusion. So we say, if Q, then R. The inverse is formed by negating the original conditional statement. So we say, if not P, then not Q. And the contrapositive is formed by both negating and flipping the hypothesis and conclusion. Here is an example of a conditional statement. If Charlie has a cookie, then he is happy. And that is true. The converse is if Charlie is happy, then he has a cookie. This is false because he can be happy other times. The inverse, when we negate each piece, if Charlie does not have a cookie, then he is not happy. Again, this is false because he can still be happy. And then finally, the contrapositive. If Charlie is not happy, then he does not have a cookie. And that is true because he doesn't have a cookie. And then finally there at the bottom is the biconditional statement. And a biconditional statement is written from both the conditional and the converse. So you take the two pieces, the hypothesis and the conclusion, and you put if and only if in between. Charlie has a cookie if and only if he is happy. And that's actually a false biconditional because the converse is false. In order to be a true biconditional, both the conditional and the converse have to be true. Then there is the law of detachment. And the law of detachment says that in a conditional statement, if P, then Q, if the P statement is true, then the Q statement is true. For instance, if your parents are teachers, then you will be embarrassed. Madeline's parents are teachers, so we can conclude she's embarrassed. But in this second case, Madeline is embarrassed, but we can't conclude it's because her parents are teachers. Then there's the law of syllogism. And in the law of syllogism, we have P, Q, and R statements, where the hypothesis of one statement is the conclusion of another. So in the law of syllogism, you have if P then Q, and if Q then R, and your final conclusion will be if P then R. Make sense?
Yep.
If you do a back handspring with sandals, then your sandal will fly off. If your sandal flies off, then you will fall down and laugh. Then I suppose I can conclude that if Maya does a back handspring with sandals, then she will fall down and laugh. Thanks for thinking outside the box with me today. See you again soon.